Hello, my dear students. This is the second to the last of our lecture series on electrical circuit, and here we are going to talk about electric power. So, our goal here is to introduce the several equations for computing power, as well as solve some sample problems, including calculating the power requirements of your devices, as well as your energy consumption in terms of per day or per month. So what you can see here is, again, a segment of a wire, and there are electrons, again, that are passing through your wire. But what I want to highlight here is, what I want you to remember here is that your wire is composed of several atoms that are bonded through metallic bonding. They are placed next to each other like this. So what happens is your electrons would bump or would collide with these atoms, the atoms of your wire. The electrons would collide with the atoms of the wire. And when that happens, some of the electrical energy that is on the electrons pass are passed on the atoms of the wire. And what happens in that scenario when that happens is the electrical energy is transformed into other forms, particularly heat energy. As a result of the collision between the atoms and the electrons, some of your electrical energy will be transformed into thermal energy or into light. And sometimes that is the goal. Like for example, your in your light bulb, what you have there is a filament, the filament that is inside your light bulb. And it is made up of material that glows when it heats up. So your goal really here is for it to for collisions between atoms and electrons to happen a lot, so that it would heat up the filament, and in that way it would produce light. In some devices like oven toaster, there is actually resistive elements. When I say resistive elements, these are elements that have high resistances. So you really want the collisions to happen, because when there's collision, there is heat that is produced. And through heat transfer, maybe that can be used to cook your food, right? If you want to compute for the power that is transformed when we use our electrical devices, what equation we can use is P is equal to I times V. So power equal to the product of current and the voltage. Power is measured in terms of watts. Watts is just joules per second. So what we see here is, when we compute per power, this is just the amount of energy that is transformed, electrical energy, to, let's say, thermal energy per unit time. We already have our equation for Ohm's law, and we saw that there is a relationship between current and voltage. So maybe we can use that here. We have an equation for I, for current, which is V over R. If we substitute this with this I, we get another equation for power. So the I here becomes V over R from the Ohm's law equation. Since you have two V's, we can multiply both of them and get V squared over R. So this is your second equation. Power is also equivalent to the square of the voltage when divided with resistance. But then again, we have another formula for Ohm's law. V is equal to IR. If we substitute that here with the V here, what we get is I times R. Since we have two I's, we can put them together, I squared times R. And that is your third formula for power. So here are your three formulas for computing power consumption. Okay, let's use them in calculation. So our device here is electrical heater. It is able to draw a current of 15 amperes and it is designed to work on 120 volts power supply. So how much power does it require? Okay, so we are given with current I and voltage V. So we can use the first formula, I guess. P is equal to I times V. Let's just get the product of 15 and 120. That's 1,800 watts. We can always convert our watts into kilowatts. Just divide it by 1,000. Okay, so you move the decimal places 3 times to the left and you get 1.8 kilowatts. That is the power requirement of that heater. How about problem number 2? Here, you see watts here. So you expect that this is the power rating and it is of the headlight and it's designed to work on 12 volts power line. So you are given with power and voltage and you are asked to get the resistance. I guess the second formula will work for this problem, but we need to do some rearrangement, right? Since we are getting resistance instead of power. So let's just exchange places. Substituting the variables or the values. So 12 squared divided by 40, that's equivalent to 3.6. Your unit for resistance is ohms or mega. So 3.6 ohms. Sample problem number 3. So we have a device. Your voltage rating is 240 and it draws 2 amperes of current. We have to calculate two things. First, the power usage or power requirements in watts, as well as the energy consumption. Energy consumption is rated as or measured in kilowatt hours. Okay, first power. Let's solve for power. We have voltage and current, so I guess we're just multiplying them. For 80 watts, let's convert that to kilowatts. So that's 0.48 kilowatts. Okay, so we already have kilowatts here. We said that the unit for energy consumption is kilowatt hour. So in order to arrive on this unit, we just have to multiply 3 hours, right? So our electrical consumption is just multiplying the 2.48 kilowatts times 3 hours. That's 1.44 kilowatt hour. That's our answer. Okay, sample problem number 4. We have a light bulb with a power requirement of 150 watts. And you have to put it on a 120 power line. Now we are asked to get the current, I guess. Calculate the current and as well as the electrical consumption. If you use the light bulb for 6 hours per day, we need to find out the monthly consumption in terms of kilowatt hour. Here we are going to assume that a month has 30 days. Okay, but first, current. We can use the first equation, of course, but we have to do some rearrangement. Current is equal to power over voltage. You can take note of this equation. If we do the division, 150 watts divided by 120 volts, it's 1.25 amperes. Okay, so that's our current. How do we get to monthly consumption? First, let's do the daily consumption first, because it is said that we use the light bulb 6 hours in a day. Again, what we want is kilowatt hour. Okay, so our power is 150 and then 6 hours. So 900 watt hour per day. But we have 30 days. We are using it for 30 days. So I guess we also need to multiply this by 30. If we multiply 900 by 30, we get to 27,000 watt hour. Again, they want it in kilowatt hour. So let's divide this by 1,000. and you get 27 kilowatt hour as your monthly consumption.